Good evening, Doctor. I'm Dharma. Together with me, GUHADARSHINI, we'll be presenting on generating a 20,000 bit random string and validating its randomness using the mono bit test from FIPS 142 standard. So for this assignment, we use Python to generate the outcome. The next slide on the step 1 generating 20,000 bit string. In this step, we develop a function called generate bit string, and this function basically generates a binary stream of 20,000 bits where each of the stream is either 0 or 1, and it uses a random method using random.radian where it only choose either 0 or 1, and this method basically ensure a uniform distribution for the binary testing. So over here you're able to see the code from Python where we have included the length is equal to 20,000 and it only uses 0 and 1. So below here is the stream. One, we have three streams, 1, 2, and 3, and each of them generated a 20,000 each stream. So for this screenshot purpose, we have only shown 100 bit.
Hi, Doctor. My name is GUHADARSHINI. Let me explain on step 2 on what we did. We applied the monobit test to check the randomness of a 20,000 bit stream. This step simply counts how many ones are present and compares that count to a range defined by the FIP 140-2 standard, which is between 9,725 to 10,275. If the count of ones falls within the range, we say the stream is statistically balanced and it passes the test. If not, it may indicate bias, example, too many zeros or too many ones, which weakens the randomness. As shown in the code, we use a simple function called a monobit underscore test. It sums up the number of ones using some bit underscore stream and returns passed if the count is within the range, or failed if not.
Slide step 3, repeat until the stream passes. Calculate the number of bits of zeros and ones. After generating the bit stream, we uses the mono bit test to validate the randomness. And if the number of ones in the stream is not between 9,725 and 10,275 as required by the FIPS 142 standard, the stream is rejected. The run cycle function is responsible for this process, and if it continues to generate the new stream until a one or a valid one is found. So each of these atoms is calculated based on the number ones and zeros, and it checks if the stream is pass or fail. So over here, this is the step 3 where it repeats the stream passes, and on the right is where it counts for the numbers of ones, and below here is the count for zeros where basically take the 20,000 minus with counts with 1, and below here is you're able to see the pass stream for 1, 2, and 3. On the next slide, on the screenshot of the code, on the right we have the full bit string where it shows the 20,000 bit string bit, and on the left is the full code starting from step 1 to step 4.
Now let us look into step 4. We repeat the entire process from step 1 to 3 by doing it 3 times to generate 3 successful bit streams that passes the monobit test, as mentioned in the question paper. Each iteration creates a new 20,000 bit stream. Now if you look at the code on the right, the function run underscore all runs this cycle 3 times using a loop inside the run cycle function. The actual generation and the monobit test validation happens here. For every valid stream, we store its details such as the stream index, bit counts, and the cycle count in a list called accepted underscore streams. The output is then printed clearly after each successful run, and once all three streams passes, the process is completed. So this is the output of the all three streams. So that's all for our lab presentation. By this, we can conclude that the pseudo-random number generator, which has a deterministic nature, still can produce sequences that appear random when evaluated properly, such as the monobit test, where it ensures whether the output streams maintains a balanced distribution of zeros and ones, which is the key indicator of randomness. This statistical test, like the PRNG, ensures their output is suitable for application in cryptography, where randomness is critical. Thank you, Doctor.